welcome to another session. In this video I'm looking at triple integrals over general regions. So let's recap. For double integrals, we were able to integrate double integrals, so let me say two integrals over general regions. Now the intuition here is that we have integral 1, integral 2. We applied some rules. The rules are such that over general regions, this is called the inner integral, and this is the outer integral. It's also said that the outer integrals are always constants. That was the rule. And the inner integrals becomes a variable of the outer integral respect to the outer. So this means that if I have a double integral as this and I have the x dy, it means that my inner integral depends on x, the outer depends on y. So the outer here, y takes some constant variables, and then x will be some function respect to y. In the same way, if I have it as dy dx, this is the inner integral, this is the outer integral. It means that x becomes some constant variable, and then y becomes some function respect to x. In the same way, if I'm considering three integrals, over a general region, there are some properties or rules to play along. So I have integral 1, integral 2, integral 3 dv. This is my inner integral. This is the middle integral. And this is the outer integral. So the same rule applies here. This means that the outer integrals will take some constant values. The middle integral will depend on the outer, so it will be a function of the outer. The inner will be what? A function of the other two integrals. So let's take an illustration here. If I have integral this, the x dy dz. Oh, let me get that well. This means that my inner integral respect to x, the outer is respect to y, sorry, the middle, and then the outer is respect to z. This means that z will take some constant values a, b. Y will depend on a function respect to z, and then x will depend on function respect to y and then z. That is what this means. So let me go through the slides here. So the rule says that the limit for the outer integrals are constant. I've explained that the limit for the middle integral can only involve one variable depending on the outer, and then the inner integral depends on two variables, that is the two other integrals I have here. Now remember that in the double integral we were slicing through some x-axis and y-axis. So if I'm taking this aspect of the double integral, you realize that I'm slicing through the x-axis. In the same way, if I take this aspect of the integral, I was slicing through the y-axis. Now the same rule applies to triple integrals. So I'll take through the slices here. Now if I'm slicing through the z direction, I have x, y, z. A function depends on, let me take a new sheet here. So I have a function depending on x, y, z. That is my volume, the v. If I'm slicing through the z-axis, so I have the z, the y, the x. This means that my z here takes a variable depending on what, x and then y. This one takes a function respect to just x, and then this one takes constant. X will be constant. If I'm slicing through the y-axis, it means the y, the z, the x. Now realize that I can interchange this one to make it the x, the z. The same way I can interchange whatever is here to make it the x, the y. It will hold. If I'm taking the x, the y here, it means that my x will be a function of y, and then the y will take constants. All right. So let me take this example. This means that this inner one, which is y, will be a function of z and then x. This middle one, which is the z, will be a function of x, and then this last one takes x as constant. Now someone can decide to slice through the x-axis. So the x, the y, the z. So in the same way, as far as the x is the slicing axis, it means this part can be written as the z, the y anyway. So this means that this will depend as a function of y and then z. This will be y as a function of z, and then this is z taking some constants. This is how we operate by the rule. Right. So looking at my figures here, that is what I have explained. Now let's take a quick example. So I'll take a next slide, so a next sheet. This example says that we want to evaluate a triple integrals over a solid figure bounded by the following planes. Now it is quite difficult to plot 3D, three-dimensional figure by hand, so we have softwares to help us. Unlike this 2D, where we're able to plot our domain, but here it's quite difficult using hand. But we have a way to construct our limit of integration. So the function f, y, z is given as z. I have the boundaries as s equals 0, y equals to 0, z is equal to 0, and then I have some x plus y plus z equal to 4. We are supposed to graph this, but we can't do that by hand. At least we know the limits given. Now the question is, how are you finding your domain or the area, which is the dv? So let's quickly go through that. Let me take it as x-axis. So I want to extend this one, the sheet here. Okay. So let's assume x-axis. And then let's assume as the y-axis approach. And then the last one as my z-axis. If I want to slice through the x-axis, it means I have a triple integral. The x, I can have it as the y dz, or the z dy. In the y-axis, it means I have it as dy, then the other two comes into play. You must note how to write it. They can change positions. The most important thing is what you are slicing through. Now the z, in the z-axis, I have the z, then I can have the x dy. Or this, I can have it as the y dx. So here I can have it as the z dx. Anyway, and here I can have it as the z dy. Any way you want to rewrite it. By the Fibonacci theorem, we are good to go. You realize that it means I expect this inner integral to be x depending on some y and then z. I expect this to depend of y respect to z. and I expect this one to be some z of some constant. If I come to this side, I expect y to depend on x and then z. I expect this one to depend on z, and then the last one will be z taking some constants. The same way, if I come to the last part, it means my z depends on some x and y. My x will depend on y, and then my y should be some constants. So how do you obtain these ones? I already have, if I want z to be constant, it means I want to find a function with respect to z. So for the first case, since I want x as a function of that, you realize that I can depend on the last boundary given as x plus y plus z is equal to 4. That is what I'll be using to compute out all the other domains. So the first case, I'll still continue. It means I want to find x as a function of y, z. I can make x the subject here, and I'll have 4 minus y minus z. I've obtained x as a function of y and z. Now the second point, if I want y in terms of z, I have to set this to 0. Let me do this one. So if I set x to 0, then I have this. This implies my y should be equal to 4 minus z. If I set this to 0, it means I can have my z to be 4. Then I can rewrite my triple integral as 0 to 4 for z, and then 0 to 4 minus z, and then 0 to 4 minus y minus z of the function given dx, dy, dz. So I'm choosing equation 1, equation 2, and equation 3. That is how I obtain the limit for the first case through the x-axis. Now the second case, it means that because I want y to be a function of x and z, it means I want to make y the subject from here. So y becomes 4 minus x minus z. If I set to 0, I have 4 minus x minus z. This implies I can find the other variables. Which one do I want? I want the x as a function of z. So I have to make x the subject. So x will be equal to 4 minus z. If I set this to 0, then I can find my last value of z to be equal to 4. So equation 1, equation 2, and then equation 3. Now how would I obtain my triple integral? So I have 0 to 4, 0 to 4 minus z, and then 0 to 4 minus x minus z, for which one? dy, dx, dz, as expected. Now the last aspect of the equation, let me change the pen. You realize that z is a function of x and y. It means I want to make z the subject, so z will be equal to 4 minus x minus y. This is my first equation. If I set to 0, I want the next to be x in terms of y. It means make x the subject. X is the next variable. So it implies I'll get x to be 4 minus y as equation 2. The next variable is the y as a constant. If I set to 0, 0 equal to 4 minus y, which implies my y is equal to 4 as the third equation. Now I can write my triple integrals with their limits. So 0 to 4, 0 to 4 minus y, and then 0 to 4 minus x minus y. This is the z dx dy. And this is how you obtain your limits of integrations for general regions. You must know which of the regions you are sliding through and then write it out. So I'll take the next example in the next video.